So let me quickly define some formula here. Okay, I think gamma function, gamma of n is defined as gamma of n. It's a kind of integral. Okay, that is defined as integral 0 to infinity, infinite integral. Okay, we need to work some infinite integral because infinite integrals will come in our quantum mechanics. Suppose I have written normalization integral. That normalization integral was infinite integral, isn't it? Like that, many infinite integrals will come. So finite integral we can do. Again, for infinite integral, we should have some what you call formula and some logic. And is that okay? That's what we can quickly go through. So 0 to infinity, x power n minus 1 e power minus x dx. So this is defined as gamma of n. This is defined as gamma of n. But we are interested in most general form, not in this form. We are interested in most general form. I need this one, 0 to infinity, x power n. Usually, I'll not prefer to think as, again, if I have x cube, if I see this formula, I have to write it as x raised to 2 minus 1, isn't it? That's quite, what you call, hectic. So, x power n into e power minus a into x. So this is the most general. This is the most general one. X power n into e power minus ax dx. So since I have n here, in case of n minus 1, you have n here. In case of n, that is plus 1 added here, that will become gamma of n plus 1. Is that okay? And divided by a power n plus 1. And you should remember this formula. So, combiningly, the most general formula is 0 to infinity. So, x power n into e power minus ax dx. So, there are some theories behind that one. I mean, we should take it as a limit actually. We should define infinite integral like this. Suppose if you have 0 to infinity f of x dx, that is defined as 0 to some a. So, limit a tends to infinity. This is how it is defined. Any infinite integral, it is defined as a limit actually, because infinity is not any real number, isn't it? That's why we define it like that. Now look at here. So 0 to infinity x raised to n into e power minus ax, that is defined as gamma of n plus 1, gamma of n plus 1 divided by a power n plus 1. Now I have to define the property of that gamma. Okay, where gamma of n is simply defined as, so 0 to infinity x power n minus 1 e power minus x dx. So that's equal to gamma of n. Now we can prove one thing here. Again, I am not getting into those proofs. Okay, so gamma of n can be written as n minus 1 gamma n minus 1. I am not taking any proofs here, okay? I am just defining some formula. At the end, I list out all formula that you have to by heart and quickly reproduce. Is that okay? Gamma of n can be written as n minus 1 gamma n minus 1. Or if you have gamma of n plus 1, you can write n gamma n. Or n plus 1 minus 1 gamma n plus 1 minus 1. I hope you got this formula. This is a property we can prove. I think using this integral only we can prove this one. So I too don't remember exactly how to prove all of these. Okay, you have to see some integral calculus book, some BSc level mathematics book. They will prove all of this. So I need this property. I need this property. Is that okay? Now, so if n is positive integer. If n is positive integer, so gamma of n, look at here, I will write it as n minus 1 gamma n minus 1. Is that okay? Now again I will apply the same rule for gamma of n minus 1. How do I write? How do I write gamma of n minus 1 according to this rule? N minus 2 gamma n minus 2. Isn't it? Like that I can continue. Suppose if you have gamma of 4, you can write 3 gamma 3. Okay? Then again gamma of 3, you can write it as 2 gamma 2. Just try to understand this formula, this property. So like that again, so 3 into 2 into, you can write it as 1 gamma 1. Is that okay? So like that you can just proceed here. Like that you can just proceed here. And you can write the formula if n is positive integer. Like that you can proceed and you can write gamma of n is equal to n minus 1 factorial. If n is positive integer, gamma of n is equal to n minus 1 factorial. Or so in turn gamma of n plus 1 is equal to n is replaced by n plus 1, that's equal to n factorial. Is that okay? So if n is integer, you can write this formula as n factorial divided by a power n plus 1. Is that okay? So gamma of n is equal to n minus 1 factorial if n is integer, if n is positive integer, or gamma of n plus 1 is equal to n factorial if it is integer. Is it clear? If n is positive integer, you can continue you can just continue like this and you can have this formula. And if n is half integer, how to write this? Again, this is true for whether n is integer or half integer. True for integer and half integer. Values of n. This formula is true for integer as well as half integer. If it is integer, you can write these two formulas. You can successively do the same step and you can write these two formulas. So now if it is half integer, suppose if I have gamma of 3 by 2, gamma of 3 by 2, then 3 by 2 minus 1 gamma 3 by 2 minus 1, am I right? So that's equal to half gamma half. Now you can't define one more step. Why? You will get negative quantity. Half minus 1, that's a negative quantity. That's why, so you should end over here and you should find that gamma of half. Gamma of half. So again, whatever the gamma of half integer, suppose 5 by 2 is there, then you can write 5 by 2 minus 1 gamma 5 by 2 minus 1. Okay? So that is nothing but 3 by 2 gamma 3 by 2. I'll keep this 3 by 2 outside. This gamma of 3 by 2, I'm going to write half gamma half. Just like I have written here, half gamma half. Is that okay? Ultimately, this will remain and I need to find that gamma of half. Again, I'm not getting into any proof. I'll directly give the value of gamma of half. Is that okay? So this gamma of half is root pi. Gamma of half is root pi. That also you should remember. Is that okay? Let me list out all of this. Okay, at the end, let me list out all of this. So gamma of, so you should remember this one. Gamma of n is equal to n minus 1 factorial if n is integer. And you should by heart one more thing. Gamma of half is equal to root 5. If it is integer, you can use this one. If it is half integer, you can reduce to gamma of half using this property. Suppose if you have gamma of 7 by 2, again by successive, again using this property successively, you can convert it to gamma half. Is that okay? So now let me define this gamma half integral, okay, so that we shall have some more idea on this one. What is this gamma of half? Look at here. A gamma of n is defined as integral 0 to infinity x raised to n minus 1 e power minus ax into dx. Am I right? Sorry, e power minus x into dx. Am I right? Gamma of half is, in place of n, if I put half, 0 to infinity, x raised to half minus 1, x raised to minus half, e power minus x dx. E power minus x dx. So that is nothing but 0 to infinity e power minus x divided by root x dx. Gamma of half is nothing but this integral, and somehow they prove that this is equal to root 5. Yeah. Actually, I lost my integral calculus book. Otherwise, I could have given that proof also. I had that book, Integral Calculus by Golden Math Series. For BSc, there are many books by Golden Math Series. So again, Integral Calculus by Golden Math Series. Again, that's in that book. Again, he discussed a lot of the proof and all. Okay, and that Integral Calculus book is very good for practicing integration also. BSc level integration. Yeah. Gamma of half is equal to root 5. Now let me do one small substitution and try to convert this integral, okay? Because I can have some more integral answer. What I do is I am going to put root x is equal to y. Then x should be equal to y square. Is that okay? Root x is equal to y. X should be equal to y square. Is that okay? So now, if root x is equal to y, 1 by 2 root x dx is equal to dy. Let me substitute. So what I am trying is, I have this integral 0 to infinity e power minus x by root x dx. I am trying to do some substitution and convert that integral. So then I'll take this 2 here, dx by root x, that's equal to 2 into dy. Isn't it? 2 into dy. So that this integral, again, I need to change the limit also, isn't it? After substitution, I need to change the limit. So now, if x tends to 0, definitely y tends to 0. Isn't it? If x tends to 0, y tends to 0. Yeah, if x tends to infinity, yeah, y tends to infinity. That's correct? That's correct, isn't it? So that is equal to, so 0 to infinity. Any changes? No. No changes. If x tends to 0, y tends to 0. If x tends to infinity, y tends to infinity. Isn't it? No change in the limit. So now e power minus, what is x here? Y square. What is this dx here? Or what is this dx by root x here? That's equal to 2y, 2 dy. So that I can write 2 times 0 to infinity e power minus y square dy. E power minus y square. I'll talk about that one lot many times, okay? Because that is Gaussian. Variable doesn't matter. Don't think about x or y or z. Is that okay? E power minus y square. That's a Gaussian. That's an even function. Is that okay? So e power minus x square, we call that one as a Gaussian. If you plot that one, so e power minus x square, is that okay? Look at it. As x tends to positive infinity, then also it will decrease. Am I right? E power minus very large quantity. When x tends to negative infinity, x square is positive only. It will decrease. It will decrease in positive as well as negative side, but it will have very smooth, what you call maxima. This is e power minus x square. Or again, I'm changing some other variable. Symbol is changed here. Okay, nature of the function will not change. E power minus x square as a function of x. Try to plot this one using GeoGebra. Is that okay? Gaussian, bell-shaped curve, bell-shaped curve. Symmetric. E power, again, if I take this one as f of x, f of minus x is equal to f of x. Am I right? f of minus x is equal to f of x. Now, I told you one rule here. So, if you have even function, now look at here. What is this one? This is gamma of half. Am I right? Gamma of half, that's equal to root pi, isn't it? The answer of the integral is root pi. No, not Gaussian is a function. I am talking about integral here, okay? Gaussian is a function. Again, he asked that 0 to infinity also represent Gaussian. Are you getting my point? Integral, you can do the integral. Again, you have e power minus x, where you can integrate minus infinity to plus infinity or 0 to infinity. It's left to you, isn't it? Now look at here. If you have even function, if you have symmetric limit, I think I gave one rules yesterday, isn't it? Some note on formula. Look at here. If you have symmetric limit, if you have function like this, if this is even function, that will become 2 times 0 to a f of x dx. If f is even. If f is even function. So that's equal to 0 if f is odd function. I hope I told some logic. In the old video that I have applied. Suppose if I take some odd function, is that okay? If I take some odd function is x cube. F of x is equal to x cube, suppose, as a function of x. How does it look like? X cube will look like this, isn't it? Asymmetric. Now, if you integrate from -1 to +1, suppose. -1 to +1. What is meaning by integration? Integration is nothing but area under the curve. Now you will get negative area here, you will get positive area here. Equal and opposite values. So that's why if you integrate that x cube -1 to +1, x cube dx, that will be equal to 0. Odd function. Odd function, area under symmetric limit. Symmetric, it should be symmetric about origin. Are you getting my point? If you take here -2, if you take here +1, -2 to +1, then that will not be 0 because this negative area will dominate. So that's why you can apply the same logic here. If it is even function, remember, function need not be always even or odd, okay? It can be neither even nor odd. Suppose exponentially increasing function. That's neither even nor odd. If it is even function, so if limit is symmetric, then that is nothing but area under the curve, isn't it? That area under the curve can be written as twice of area under the curve from 0 to a. Let me give one more example of some even function. Suppose let me take it here, okay? Is that okay? -1 here, so +1 here. Now look at here, area under the curve of this one, total area under the curve from -1 to +1, that is equal to twice the area under the curve from 0 to 1. So that's what this one, in case of even function. In case of odd function, that will be 0. If limit is symmetric. Don't apply this rule if limit is not symmetric. Symmetric, I hope you got the idea. If limit is symmetric about the 0, -a to +1. If it is from a to b, then don't apply. If a is not, if it is not symmetric. Is that okay? Take these two ideas, this one and this one. If function is even, that is twice the area under the curve from 0 to a. If function is odd, that will be 0. Positive and negative area, they will add up to give 0. So along with this one, along with remembering this one, you should remember some more formula regarding this. Integral -infinity to +infinity e power minus a into x square. This is also Gaussian, okay? Now, so as a homework, you plot these curves, okay? E power minus x square, okay? E power minus 10x square, e power minus 100x square. Try to plot this one. As a homework, write it down. Try to plot this one and you will experience what will happen. And I will give a lot of physical interpretation while doing quantum mechanics problem on this one. Is that okay? Try to plot this one, e power minus x square minus 10x square minus 100x square. Similarly, e power minus x, e power minus 10x, e power minus 100x, exponentially decaying. Is that okay? You will understand what is the role of this coefficient. Shape of the curve almost remains same, but role of the coefficient will be there. If you keep if you make this value larger and larger, it will fall off quickly. Suppose if you have e power minus x square, this curve is like this, suppose. Is that okay? So e power minus 10x square, so it will be little sharper. Is that okay? Not that wider, actually should be symmetric. It will be sharper and sharper because this coefficient will help it to decay quickly. Is that okay? So try to plot this kind of curve. You will understand a lot of things. Try to grab that mathematical basics. So minus infinity to plus infinity, e power minus ax square dx. Okay. So that is nothing but root of pi by a. Actually, we have done 0 to infinity, 2 times 0 to infinity e power minus x square dx, or e power minus y square dy. I have written y square dy, I have changed the symbol. Is that okay? That's equal to root pi. Am I right? Now what I do is, I am going to absorb this 2. I am going to write it as minus infinity to plus infinity because it's an even function. Look at here. Because this can be written as 2 times 0 to infinity because this is even function. This is generalized here. This integral is generalized here. Later, I'll give some list of formula. Again, you can solve any of that gamma or Gaussian integral using that formula. Curve will become narrower and narrower if you increase this coefficient actually. Is that okay? If curve become narrower and narrower, look at here, if A is larger, then area under the curve. This whole thing is area under the curve, that will decrease. It's in the denominator, isn't it? Whole thing is area under the curve. Full area under the curve of Gaussian. That will decrease because A is in the denominator of the answer. That's it. Yeah. I need one more. It is similar to this one, but it needs a lot of substitution and rearrangement. Okay. Minus infinity to plus infinity, e power minus ax square plus bx plus c. I need this integral. I'm going to use this one very many times. If b and c are 0, this should be equal to root of pi by a. That's why this root of pi by a will be there. Along with this will be equal to e power b square minus 4ac divided by 4a. You should be able to apply this one many times. In case of Fourier transform, it is very helpful actually. Fourier integral and all. Note this term. This is very important integral. And one more, last one is 0 to infinity. Remember, 0 to infinity, not minus infinity to plus infinity. 0 to infinity. X raised to n into e power minus ax square dx. E power minus, again, this doesn't have x square here. Observe properly. Is that okay? This doesn't have x square here. You have Gaussian multiplied with x power n. This can be written as 0 to infinity. Okay, this can be written as 1 by 2 into a power n plus 1 by 2 gamma of n plus 1 by 2. So am I right, Ritish? This one. I think that's right. 2 into a power n plus 1 by 2, n plus 1 whole divided by 2, gamma of n plus 1 whole divided by 2. And I think you need to by heart this. And again, you should not forget that gamma of half is equal to root 5, because whatever you have, if you have integer here, you can reduce it to factorial. You can write in terms of factorial. If you have half integer, you can reduce that one to again gamma of half, which is equal to root 5. Is that okay? Wait a second, let me list out all of them again for a practice. Now, one thing you should remember, if you have product of two functions, so that's equal to even if both f of x and g of x are even. I hope you know what is the even function, what do you call, idea. F of minus x is equal to f of x, that is even function, isn't it? So now look at it. If both f of x and g of x are even, that's equal to even. Odd, if either f or g are odd. Or, let me write it. If it is odd function, if f is even and g is odd, so f is odd and g is even. If you multiply even function to odd function, that will become odd function. Suppose if I take f is even, g is odd. F is even means f of minus x is equal to f of x. Am I right? G again, g is odd means g of minus x is equal to minus g of x. Am I right? If you multiply both of them, let me write it as capital F of x, that is f of x into g of x. Now, if I see the nature of this function, look at here, f of minus x, that's equal to, I have to change x by minus, f of minus x, g of minus x, isn't it? Here, f of minus x will not change the sign, that's equal to f of x itself, isn't it? G of minus x will change the sign, isn't it? Minus g of x, that's nothing but minus of capital F of x. F of minus x is equal to minus of capital F of x. So that's why product of even and odd function, that's equal to odd function. Product of even and even function is equal to even function. Product of odd and odd function is even function again. Why? If you change one negative, again both of them will change the sign, and so as a result you will get positive sign. Is that okay? So that's why try to prove it like this. So it's equal to even if both f of x and g of x are odd. If both of them are odd, if you change the x by minus x, both of them will lead to one negative sign, so that as a result positive sign. If they are both are odd, if both are even, then the resultant function is even function. It is odd if one is even function, other is odd function. Is that okay? So try to grab this idea. Again, I don't think you have to write this one. You should have this idea. Even function into even function is even function. Odd function into odd function is even function. Odd function into even function is odd function. Is that okay like that? Yeah. Gamma of 1 by 3, I think I don't know how to define. Okay. So not all integrals are defined here. I'm talking about half integrals. Integral or half integral value. Either we work with integral or half integral. Is that okay? I think gamma of 1 by 3, that will happen to be some other type of integral. Yeah. Now I'll give some examples. You should integrate minus infinity to plus infinity x square into e power minus ax square dx. Integral 0 to infinity x cube into e power minus 2x dx. Integral minus infinity to plus infinity x cube into e power minus ax square dx. Integral 0 to infinity x into e power minus ax square dx. First one, second one, third one, fourth one, fifth one. Integral minus infinity to plus infinity e power minus ax square into e power I bx. You should use e power minus ax square plus bx plus c formula. Is that okay? Like that. So try to do this one. Let me do some of them. Okay, so try to write it like this: minus infinity to plus infinity, e power minus outside ax square plus minus ibx plus c into 0. Isn't it? So you can manipulate this one like this. You can manipulate by taking negative sign outside, because so what you had, the integral that I had given is e power minus of ax square plus bx plus c, isn't it? And your answer is so related to that. So in place of b you have minus I into b. Okay? In place of a you have a. So try to solve that integral. Is that okay? Now let me do. So what is this one? How do you solve this one? Again, according to the formula that I gave. How do you solve this one? First one. How do you solve this one? Minus infinity to plus infinity, x square into e power minus ax square dx. Now observe this one. X square is even function. E power minus ax square is also even function. Why? Because if you change x to minus x, it is not changing sign. If you change x to minus x, it is not changing sign. Even function into even function, even function. That's why you can write 2 times 0 to infinity x square into e power minus ax square dx. Check it out. And I gave formula for 0 to infinity. And apply that one. 2 into, what is this one? 0 to infinity x power n into e power minus ax square. I have given it like this: 1 by 2 into a power n plus 1 by 2, 2 plus 1 by 2, gamma of 2 plus 1 by 2. So that can be written as 2 got cancelled, 1 by a power 3 by 2, gamma of 3 by 2. Gamma of 3 by 2 you can write it as, so half gamma half. What is gamma of half? Root pi. Half into root pi. That is your answer. Practice this one, okay? Practice this one. All of this integral, whatever I have given, practice this one. You can do most of the integral using the formula that I gave. Now, how do you do this one? Third one, quickly. How do you do third one? Third integral. X cube into e power minus ax square. Odd function. Limit is symmetrical. Then speak out. It's okay. 0. Isn't it? Area under the curve, because one positive area, one negative area, it will be 0. It's 0. Is that okay? But what about this one? X is odd function. X power 1, that is odd function. E power minus ax square, that is even function. Am I right? But you have limit 0 to infinity, not symmetric limit. You are trying to find the area in the only positive x-axis. This need not be 0. Is that okay? This need not be 0. So that's why I gave the formula for 0 to infinity of x power n into Gaussian. Is that okay? If you have 0 to infinity, x into e power minus ax square. Or if you had 0 to infinity here, that would be non-zero. Since you have minus infinity to plus infinity, that is 0. dx. What is this one? 1 by 2 into a power, whatever the quantity here, I have taken it as a. Later some other quantity will come here. Is that okay? Some, so pi h bar like that. Is that okay? In case of quantum mechanics. Yeah. 2 into a power n equal to 1 here. 1 plus 1 by 2. So gamma of 1 plus 1 by 2. Isn't it? That's equal to 1 by 2 into yeah 1 by 2 into 1 by a into, am I right? A power 2 by 2. Gamma of 1 is 0 factorial. 0 factorial equal to 1 again. Isn't it? So that's equal to 1. So like that, do this one, 0 to infinity, do this one, 0 to infinity, x cube into e power minus ax square dx. This is non-zero, don't write 0 because odd function, that is okay, but limit is not symmetrical. Is that okay? Be careful while writing that one 0. This is 0. So don't think about odd or evenness here. Look at it, x cube is odd, but e power minus 2x, neither even nor odd. I get my point, that is neither even nor odd. We will not work with minus infinity to plus infinity because it will diverge actually. That will diverge if you integrate from minus infinity to plus infinity. You can integrate only between 0 to infinity. I mean, area under the curve will become infinity. Because again, if you plot this one, you will understand. Try to plot that one using GeoGebra. Okay? Now quickly, let me list out all of the formula, whatever I told you to remember, and then try all of this one. I hope you have written that one. You have written the example I have given. Yeah. So first one, I have started with this one, 0 to infinity, e power, again, x power n into e power minus ax into dx, exponential integral. This have got, again, this area under the curve is finite only from 0 to infinity. Because e power minus ax, if x is negative and large, it will be increasing function. Isn't it? E power minus x, if you plot, it will be like this, isn't it? E power minus x. If you take area under the curve from minus infinity to plus infinity, it would be infinity. Isn't it? Area under the curve. So that's why 0 to infinity, that is finite. That's equal to gamma of n plus 1 whole divided by a power n plus 1. Gamma of n is equal to n minus 1 gamma n minus 1. Gamma of n is equal to n minus 1 factorial if n is positive integer. So gamma of half is equal to root pi. Minus infinity to plus infinity, this will come frequently, that's why you should remember this one directly, e power minus ax square dx. That's equal to root of pi by a. Minus infinity to plus infinity, e power minus ax square plus bx plus c dx. That's equal to root of pi by a e power b square minus 4ac divided by 4a. At the end, last formula, that is 0 to infinity x power n into e power minus ax square dx. So that is equal to 1 by 2 into a power n plus 1 whole divided by 2 gamma of n plus 1 whole divided by 2. You can solve most of the integral using the formula that I have written in the board. No, I think bracket will come here. What I had given earlier formula, what I had given? I put into bracket. Yeah, I put into bracket. Yeah. Bracket should come here. Bracket should be there. comma here, okay? It's comma. Okay? You should remember all of this formula. And you can solve most of the infinite integrals. Last one. When you keep applying that one, you will understand, okay? And again, do all of the 4 to 5 problems that I have given again, yourself. Try to just application of this formula. It needs some practice, okay? It needs some practice. No, as I remember, there should be bracket, okay? That should be bracket, as I remember. You can just, so try with G again, any computational platform. Yeah, one more thing that we may need is beta gamma integral relation, but I don't think that is much useful in our problem solving techniques. But in WKB method, I found to solve some problem, you may need that one. Is that okay? So the relation between beta and gamma function. Beta m comma n, it is defined like this actually. 0 to 1 x power m minus 1 into 1 minus x power 1 minus x power n minus 1 dx. Or you can define it like this, 0 to infinity y power n minus 1 whole divided by 1 plus y power m plus n. And somehow we can prove that this beta m comma n, that's equal to gamma of m whole divided by gamma of m plus n. Okay, to prove some, again, to do some problem. Okay, yeah, I think from next week it will not happen. Okay, no more disturbance, because I am shifting the place here. Actually, that if there is any background song like that, YouTube artificial intelligence, it will detect that one and it will show copyright issue. After closing this session, I think it will send one email or something. It will show some copyright issue, because that song will have copyright issue in a whole YouTube platform. No, I don't think the bracket should be there, okay, in this integral, e power minus ax square plus, okay, if it is minus ax square plus bx plus c, no, this is not the formula, okay, minus ax square plus bx plus c, it is in the bracket only, okay. I remember directly, I remember so properly. It's in the bracket only. Gamma of m, again, or cross check that one, okay, so cross check that one. So this is the relation, somewhere we need that one, okay, so not much important. And you better to have these two integral, we can solve it somewhere in Fourier transform or Laplace transform like that. So integral 0 to infinity, so sin x divided by x. Sin x divided by x is a even function. Sin x is odd function. 1 by x is odd function. Odd into odd, that's the even function actually. But limit is not symmetrical, you don't have to worry. So that's equal to pi by 2. Integral 0 to infinity sin square x divided by x square dx, surprisingly, it's also pi by 2. We shall verify this one, okay, integral 0 to infinity, so sin raised to 4x divided by x power 4, I think this is equal to pi by 3, put some star here, star means question mark here, okay, we shall check it out.